Hello everyone, welcome to part 2 of 3 for file I/O in Python. In this video, we'll be going over the use of the Pathlib module to handle paths instead of the OSPath module. Pathlib has been a part of Python since 3.4 and is a more modern method of handling paths. In fact, most if not all Python programmers, including myself, would highly recommend using Pathlib over the OSPath module. It's not to say you can't use the OSPath module if you want to. You absolutely can, especially if you don't need to make any crazy modifications to paths or make a bunch of paths in general. But if you do need something more, Pathlib is the way to go. Instead of just functions returning strings, Pathlib actually provides a class to create path objects, providing an easier, more Pythonic way to perform operations on them. These objects have access to methods and attributes that can do a lot of the same things the OSPath module can do, but are more convenient and readable. Another useful thing about Pathlib is that everything needed for working with files and directories is contained within the path class, regardless of whether it has to do with paths or to do with other system functions for files and directories. This is much more organized than the OS module, where some of it is in the main OS module and the rest of it is in the OS path module. And that's actually one of the reasons why it's always said to just use the line import OS when you're trying to use the OS path stuff. Oh, and just a quick note for those who may be wondering, the functions in the OS and Pathlib modules that touch on system operation stuff for files and directories will be covered in their own video. I'm not ignoring them completely, I'm just focusing on the stuff more relevant to file I/O. Now let's take a look at the Pathlib module. Alright, the first thing we need to do in order to use the Pathlib module is simply to use the import line from Pathlib import path. I'm going to go ahead and run that, and that's pretty much it. And in order to create a path object, we just call upon path and pass in at a minimum one string parameter. I have two examples here. The first one, we pass in a single string parameter that is the full path to a directory. The second path object here, we can pass in multiple string parameters, as many as we need. Each parameter is a different component of the path. So we got the directory slash, we've got the directory home, we got the directory crozo, and then the file test.txt. You can pretty much do this with any path you can think of, whether it's to get to a directory or to a file, and you can list as many individual parameters as you need for the object. So I'm going to go ahead and run this, and then we've got the two paths right here, and they both print out as POSIX paths. And that's because we created this object while running this program on Linux. If we were to run this program on Windows, it would create a Windows path. And just to show you the Windows path, from pathlib imports path, type path, we'll just say tilde, and see, it comes out as a Windows path. So it's dependent on what you run the system on. I believe Mac OS would also be a POSIX path. Getting the user home directory is a lot easier with the path object. We just call a method called home. The home method, like many of the other methods for path, will return a path object. And we don't have to create a path object beforehand in order for this to work, as you can see here. And it's still going to come out as a path, and then it's going to print out the home directory, which in my case will be /home/crozo. See? Path objects unfortunately cannot automatically handle tildes, much like the Path OS module, but also like the OS Path module, they do have an expanduser method to fix that. So all you have to do is create a path object containing the path information that has the tilde in it, then call the expanduser method, and it'll return a path object with the newly expanded path. So if I run this, it expands the tilde into /home/crozo. The string magic method is defined in the path class, which means we can either print out the string directly, which I have demonstrated countless times already, but we can also cast it as a string. And this is particularly useful because there are modules out there that will not take a path object. They will only take a string to use to open up a file. So right here, I create a path object and store it into fname, and then I store its casting as a string into fname_string. So print out the two types, and there's POSIX path and there's string. Path objects provide us multiple ways to join two or more paths together to create a new path. The first way is actually pretty cool. We make use of the division operator to combine two paths together. This will work as long as one of those paths is an actual path object. So we can combine two path objects together or one path object and a string together. And it doesn't have to be the path object first. So there could be a string at the beginning and a path object after. So in this first example, I create a path object using the home function, and then I join the test.txt file name to that path object using the division operator to create a brand new path object. So if I run that, so we got our first path home/Crozo, and then I join them together. It returns another POSIX path, and then it creates the full path that we created. And this second example here is still using the division operator, but it's also showing that you can use it multiple times. And like I said before, the path object doesn't have to be first. It could be at the end, it could be in the middle like this, and we can combine a bunch of different stuff together. So if I run this, and as you can see here, we get /home/Crozo/test1.txt/test2. I know that's not really like a real file path or anything that anyone would actually use. I just threw all that together just to show you how the division operator works. It's pretty cool. And then for this third example, it shows that path objects do have a method called joinpath that allows us to pass in a bunch of string parameters so that it can combine them together into a path object. So we'll get /home/Crozo/test.txt. Path objects also have attributes that we can call upon. Some of the more common attributes that we would call upon in the path object are the ones that allow us to extract data from the path contained inside, such as parent directory names, file names, the extensions, stuff like that. This first example, we can get the file name from the path. So when we print this out, we should get test.txt. And unlike the methods we've been calling, this is not going to return a path object, it's going to return a string. See? So it returns us a string test.txt. Here we can call the stem attribute, which will give us the file name without the extension. The suffix attribute will give us the extension of a path, if there is one. So string and .text. Anchor is a pretty unique attribute. So what it does is, if it exists inside the path object, it's going to return the file system anchor of that path. In this case, it's going to be the / because it's /home. In a Windows path, it would be the C:\/ or the D:\/ like the letter drive. I'm not entirely sure what use cases you would have for this, but if there is one, you have this attribute. So this should return the /, as you can see right here. Parent. This attribute allows us to get the parent directory of the path inside the path object we have. Whether it's the parent of a directory or the parent of a file, it will give us that parent directory. And the difference between this attribute and all the other attributes I've shown is that this one will actually return a path object. So we got /home/Crozo, and it's a POSIX path. And because parent returns a path object, that means we can stack the parent calls on top of each other. So we got /home here. And of course, what would the path class be if it didn't provide methods for checking conditional stuff? So here we have a method to check to see if a path exists. And of course, I still have the test.txt file on my system, so this should come out as true. We can also check to see if a path object contains a path to a file, as well as a directory, and whether or not it's an absolute path. And that's about it for the Pathlib module in Python. In the next video, which will be part 3 of file I/O in Python, I will cover the actual file I/O operations. So I hope you've enjoyed this video and found it helpful, and if you did, then please hit the like button and leave a comment below to let me know what you think. And if you want to see more, head on over to Wayfair Coding Academy channel to check out my other content. And while you're there, subscribe to the channel to stay up to date on new stuff as it comes out. Thanks for watching, and I'll see you all next time.